Hello everyone, I'm Raza Kayani. Today's lesson I'm going to talk about terminal velocity of falling object. You are watching revision series of high school physics. At the end of the video, I'm going to explain and solve some interesting exam questions related to terminal velocity. By the end of the lesson, you will be able to describe about weight and drag force, that is also known as air resistance. You will also be able to know the effect of air resistance on falling objects, how the forces acting on skydiver change with speed, describe what is meant by terminal velocity of moving objects, how to plot speed-time graph of skydiver moving with different values of acceleration. First of all, I'm going to talk about if an object falling from rest in the absence of the air resistance. If no air resistance acting, for example, when the object is first released from certain height under the effect of gravity, the only forces acting upon it is its own weight, because no air resistance acting upwards. The object accelerates downward with acceleration due to gravity. We denote the value of the g, gravity, by g. So that depends on the planet, basically, the object where we drop it. So the value of the g is different on different planets. In this example, if the mass of the object is 2 kilograms, an object is falling down and no air resistance acting upward. So to the air resistance, we say Fd. Fd means the drag force. If the drag force acting on the object is 0, then object fall down only with the resultant force that is equal to weight. And then what is the value of the acceleration acting? That will be g only. For Earth, that is 10 meters per second square. So in whole lesson, the resultant force we are going to denote by F. So the resultant force, F equals to, the formula for the resultant force is weight, downward force, minus the drag force that is acting upward, Fd. In this case, the weight is, like, if the mass is 2 kilograms, the weight of the object is going to be then 20 newtons. So the weight is 20 newtons. The drag force is 0. F, according to Newton's law, when there is a resultant force, so resultant force is equal to ma, mass time acceleration. So mass of the object here, if you see that object is 2 kilograms, so I can say 2a equals 20, and a equals 20 divided by 2, that's going to be 10 meters per second squared. So there will be no change in the value of the g because no air resistance is acting. So if no air resistance acts on falling object, how the graph will look like? I mean, the graph between velocity and time. Here I wrote for Earth. So for Earth, this graph is a straight gradient, is a constant gradient. So the value of the g is going to be the same. If you see from here, 20, 40, and 60, and if the time is 2 seconds, 4 seconds, and 6 seconds, and 8 seconds, then if you are going to plot the gradient, that is g, and the g equals rise over run. So in that case, if I take the point over here, for example, if I'm going to take this point and I'm going to choose this right angle triangle, so my rise is 60 divided by 6, 6.0, so that's going to be 10 meters per second squared. Now we can know about this planet. For this planet, the data that we have, also we take velocity along y-axis and we take time along x-axis, and this gradient is smooth. That means air resistance is not acting as well on it. So I can find the value of the g for this one. If I take the right angle triangle till here, so I can choose the value for the g, and in that case, the value of the g, the rise, I can take 16, and the run is 4. That's going to be 4 meters per second squared. And the value of the G that, that is 4 meters per second square, that is for the planet Mars, and Mars has no air resistance acting. Now we are going to consider when air resistance is acting on the object, then what happens? So my heading is motion in presence of air resistance on Earth. Still, I'm talking about Earth because I'm going to take the value of the G, that is 10, and the gravity I'm going to take 10. So that's why I'll consider this object on Earth. So now, when objects start falling from certain height, at that time in the beginning, the value of the air resistance is 0, so it falls with the gravity that is 10 meters per second squared. But after some time, what happens to it? So I'm going to consider the same object that has a mass of 2 kilograms. And the weight of that object, according to the formula, W equals to mg. So if the mass is 2 and the value of the G is 10, so my weight is going to be 20 newtons. So downward force acting, that is W, 20 newtons. If in this case, air resistance acting upward is 4 newtons, for example, now we have a dragging force. The drag force here is denoted by Fd, that equals to 4 newtons. Fd is 4 newtons in this case. Now there is a resultant force acting, because whenever there are two forces acting, so we can calculate the resultant force. So resultant force throughout we are going to write by letter F. So F equals W minus Fd. So I'm going to write F, my weight is W, 20 newtons, and the Fd is 4 newtons as I labeled up here. So that equals to 16 newtons. But F is what? F is ma, according to Newton's second law. So ma is 16 newtons. Mass of the object is 2. So 2 equals 16. And in this case, a equals 16 divided by 2. That equals to 8 meters per second squared. So in this case, this object is accelerating down. That is not G, okay? That is, it's less than, my value of A is less than G, because 8 is less than 10. So object is accelerating down now with an acceleration of 8 meters per second squared. So as the object speeds up, the air resistance starts, which is also known as drag force. The object is still accelerating, but acceleration is less as compared to the first case, because due to air resistance, the resultant force decreases. So resultant force is 20 minus 8, that equals to 16. Now I'm going to explain you the presence of air resistance by dropping two balls. If you have two balls, one is the rubber ball that is heavy, and there's a plastic ball that is light. You know, the rubber ball has the same weight equals to cricket ball, and that's the plastic ball. So if we do experiment in the room, we consider that no air resistance is acting. So that's falling with uniform acceleration, constant acceleration, but the plastic ball is lighter, so air resistance is acting on it. So what will happen? The acceleration starts decreasing, and it's going to reach to terminal velocity here. So what can we say, basically? What can we conclude about the graph? When the graph is a straight line, we say there is no air resistance acting. But if the graph starts bending, that means the air resistance is acting on it. So whenever there will be air resistance, our graph is not going to be a straight line. That's going to be a curved path. As the object further speeds up, the air resistance increases. The dragging force acting upward increases. The resultant downward force decreases. As the resultant force decreases, the amount of acceleration further decreases. So we are going to see with this example, we are talking about the same ball that we have dropped, and we want to investigate the acceleration of the ball at different height. So the same mass is 2 kilograms for the object, and that's why the weight is 20 newtons. And now if the drag acting on it is 10 newtons, that force upward, So see what will happen now. The FD is a dragging force, 10 newtons. Now I'm going to calculate the resultant force, and then I'm going to see the value of the acceleration. You know, what will be the value of the acceleration in that case? So the resultant force is F, that is W minus FD, the drag force, 20 minus 10, and that is MA. M is 2, 2A equals 10 newtons. And now I can calculate the value of A, 10 divided by 2, that is 5 meters per second square. So what can we conclude in this case over here? See, as the drag force increases, the value of the acceleration decreases. Now, if the weight, that is 20 newtons, and the drag force, that becomes equal now, when the both forces, the air resistance and weight, become equal, then we are going to see, you know, when it is equal, that means the FD is 20 newtons. And now we can calculate the resultant force, and we can find the acceleration of the object, and we can talk about what is the value for the terminal velocity in this case. As the velocity of the object continues to get faster, the resistive force due to air resistance and the resultant force pulling it down decreases. Eventually, the drag force is balanced by the weight of the object, as shown in the figure here to the right. The resultant force is 0. The object moves with a constant velocity called the terminal velocity. So we are going to see first value of the acceleration in that case. So resultant force is F, that is W minus FD, 20 minus 20, MA, that is 2A, that's going to be 0, and value of the acceleration, 0 divided by 2, that also going to be 0 meters per second square. So when the forces are balanced, the object is going to fall with 0 acceleration. At that time, we say the value of the acceleration is 0. So what is a terminal velocity then? The terminal velocity is the constant velocity when acceleration is 0. So we called to this term as a what? As a terminal velocity here. Now the object is moving with constant velocity when acceleration is 0. I'm going to summarize the value of the g at different height for that object with the help of the graph. So if I have a velocity time graph over here, so when we drop something from certain height, if no air resistance acting upward, in that case only downward acting is a weight, so the value of the g will be a constant. So that portion of the graph shows the value of the g here is at that gradient is 10 meters per second squared. But when the drag force start acting upwards, so the value of the acceleration is going to decrease. That cannot be constant, so it start curving then, because the value of the acceleration is less than 10. But when the both forces, the downward weight and the drag force, that is FD, when they become equal, so the value of the acceleration is 0 in that case, the A is going to be 0 meters per second square, and at A equals to 0, the object is moving with the velocity to that velocity. We say terminal velocity. So that part of the graph, basically, that part of the graph is called the object is moving with the terminal velocity in this case. So we can see the gradient. The gradient of the velocity time graph is greater in the beginning. Look, that is greater, in the beginning, and then it gets steeper here, okay? So as the air resistance increases, the gradient starts decreasing because the resultant force acting on the object start decreasing. So in that case, it's going to be 8, then it's going to be 6, 4, 2, and then 0 at the end. Now I'm going to explain the acceleration time graph for the falling object with the help of the velocity graph. So we know that as the drag force increases, the acceleration decreases. So we can see from the graph now, what is happening to the acceleration. What we have discussed in the previous graph, the value of the g over here is 10 meters per second squared, and that's going to be 8, then 6, 4, 2, and then going to be 0. Acceleration is 0 over here. Now we can see what will happen to the acceleration time graph now. So the value of the g in the beginning, that is 10. Then what happens as air resistance start acting on it, so acceleration start decreasing. So that's going to be 8 over here in this case. So as air resistance increases, the upward force increases. So the resultant force is going to decrease in this case. So objects start decelerating, which can be seen from the graph. Finally, the object is going to attain the terminal velocity over here when acceleration is 0. So that velocity is called the terminal velocity. Terminal velocity depends upon shape and area. The terminal velocity of falling object depends upon how big the air resistance is. Air resistance depends upon 2 factors. Number 1, the shape of the falling object, how streamlined it is. Number 2, the surface area of the falling object. If you see all these images, the train is streamlined, the cyclist and every single part of the bicycle is streamlined. If you see the fish, every part of the fish is streamlined. So when the object, they are streamlined, less air resistance is acting. So if the objects are well streamlined, so less air resistance is acting, so less opposing force is acting on it, so they can move faster. The second factor is the surface area. When the parachute opens, surface area of it increases, so the air resistance increases. For a very short time interval, its air resistance becomes greater than the weight of the skydiver, so the resultant force acts upwards and paratrooper decelerates. As the paratrooper slows down, the magnitude of the drag force due to large surface area increases, a new terminal velocity is reached. We can see these 2 diagrams. So in that case, the surface area is less. So if the surface area is less, so that object is going to move with the larger terminal velocity. So the speed of that object is going to be greater. So it's moving with the greater terminal velocity because the surface area is less. So the air resistance acting on the surface area is less because the surface area is less. So the chances for this object is to go faster. But for this object, it has a big surface area. So in the big surface area, more air resistance is pushing it up. So the terminal velocity of that object is going to be low as compared to the terminal velocity of the top parachute. Students love to make models of different objects. We can teach the concept of air resistance by designing different shapes of parachutes at school or university level. Jumping off a skydiver. We are going to see the forces acting on a skydiver now. When a skydiver jumps from an aeroplane without opening the parachute, the only force acting on him is weight. As the skydiver moves towards the ground with high speed, air resistance increases, and eventually it becomes equal to weight of the skydiver. When both forces become equal, there is no resultant force acting on the skydiver. He stops accelerating and travel at a constant speed known as terminal velocity or terminal speed. See, in this case, if the weight acting downward and the air resistance, the drag, that becomes 0, then the person is going to move with the terminal speed here. Now, I'm going to summarize the falling of the skydiver with the help of the graph. What we have discussed earlier, when objects fall in absence of air resistance, so what is happening in that case? What is happening in that case? The only weight is acting downward because no drag force acting upward. So he is falling down with acceleration due to gravity, that is 10 meters per second squared. After some time, a resistance starts acting on it. If the drag force now acting on the person is 100 newtons and the weight of the skydiver is 500 newtons, so he is moving down with the resultant force of 400 newtons. So on the graph, the acceleration is less, so the acceleration of the skydiver is going to be less, so we can label here somewhere on the graph. Now, what we have discussed, after some time, the weight acting downward and the drag is going to be balanced. If both forces are going to be equal, 500 newtons downward, and the drag force is 500 newtons, at that time, the object is going to move with the resultant force of 0 newtons. In that case, the object is going to move with the terminal velocity, and acceleration at that time is going to be 0. Why? Because when the resultant force is 0, acceleration of the object is 0. As the skydiver approaches very close to the surface of the Earth, he is going to open the parachute. When he opens the parachute, the upward force in that case is going to be greater than his weight. So the upward force is 700 newtons and the downward force is going to be 500 newtons. So he is moving with the resultant force of minus 200 newtons. So he is going to decelerate. So the velocity time graph in that case will look like this because he is decelerating now. After some time, again, the both forces are going to be balanced. The 500 newtons acting downwards and the drag acting upwards, again, they are going to be equal. So in that case, again, he's going to move with the terminal velocity. Again, he's going to move with another terminal velocity that is going to be low as compared to the first terminal velocity. I did research to find the different velocity of the skydiver. The average velocity is 350 kilometers per hour. And when without parachute, the terminal velocity is going to be 320 kilometers per hour. And again, after opening the parachute, the terminal velocity is going to be 190 kilometers per hour. But these are all average values because the value of the terminal velocity depends upon weather, temperature, and different regions. These are the average value of speed for the skydiver at different positions. But the value of the velocity of the skydiver changes in different conditions. Now we are going to practice some exam questions. Question number 1. When does an object falling vertically through the air reach terminal velocity? A. When the acceleration of the object becomes negative. When the acceleration of the object is equal to g. When the air resistance equals the weight of the object. When the air resistance is greater than the weight of the object. So the first option, when the acceleration of the object becomes negative, so in that case, there will be a resultant force. So that is not possible. When the acceleration of the object is equal to g, so when acceleration equal to g, then no air resistance is acting at that time. When the air resistance equals to the weight of the object, that's the correct option because at that time, objects start moving with the terminal velocity. A parachutist is falling through air at terminal velocity. Which statement about the parachutist is correct? A. Every force acting on the parachutist is equal to 0 and his acceleration is equal to 0. Every force acting on the parachutist is equal to 0 and his velocity is equal to 0. The resultant force acting on the parachutist is equal to 0 and his acceleration is equal to 0. The resultant force acting on the parachutist is equal to 0 and his velocity is equal to 0. So we are going to see the first option, A. Every force acting on the parachute is equal to 0 and his acceleration is equal to 0. That's not possible. How the forces cannot be 0? Because at A, every forces cannot be 0 because there is an upward and downward forces acting. So that is incorrect. Again, in B, every forces cannot be 0 and velocity could reach to terminal velocity cannot be 0. So that's also not correct. C, the resultant force acting on the parachutist is equal to 0 and his acceleration equal to 0. That is true, When upward and downward forces are equal, then resultant force equal to 0, and ma equals to 0, that means the acceleration is going to be 0, so that is correct option. We are going to see next question. A light object is dropped from rest. It falls at a large distance vertically through air. How can the motion of the object be described? A, constant acceleration. One thing we have to see over here, they say through air. So when there is an air, acceleration cannot be constant because the drag force is acting on it. So A cannot be the option. B, increasing acceleration. No, when object they B, increasing acceleration. That's not possible. When object they fall in the air, acceleration decreases. That cannot be increased. That's also incorrect. Decreasing acceleration and then moving at terminal velocity, that can be possible because the acceleration keep decreasing and decreasing, and finally acceleration is going to be 0 and it moves with terminal velocity. D option, increasing acceleration and then moving with terminal velocity. In the air, when air is opposing the motion, so acceleration cannot increase in that case. It's the option is going to decrease. I have collected a range of past paper questions from 2002 till 2019 from different variants being examined by the University of Cambridge worldwide. The answers to these questions are available on the website. So these questions on the top, they are from paper 4. These questions on the top, they are taken from paper 4. And these questions are taken from paper 6. Thank you for watching. Subscribe to the channel to receive the next lesson.